Binoy Kumar Das, Principal Facade Consultant from the Facade Concept Design Group. He will discuss high-rise building facade design. Mr. Binoy Kumar Das is the Principal Facade Consultant from the Facade Concept Design Group based out of Ho Chi Minh City, Vietnam. Having 22 years of experience in facade consultancy and engineering and providing comprehensive services from architectural and facade engineering and project management services to developers in the Middle East, Southeast Asia, India, Canada, and UK. Also, award-winning facade consultant in India, Thailand, and UK in 2016. Let's welcome Mr. Binoy.
The facade concept design. I based out of Ho Chi Minh City, and we have 5 offices around the Asia, and including Canada, and also in India, Mumbai. So we are one of the specialized on the high-rise structures on the facade design and how its importance in terms of designing a high-rise structures. So mostly the facade designer or a consultant has to come into the project at the initial stages when there's a complexity on the high-rise tower facade design concern. So mostly the high-rise towers, there are certain analyses which are very important before we get into the design. What kind of system need to be proposed, as unitized or semi-unitized, or any complexity on the add-on double screen or maybe a diagonal facade. That will be only decided after the analysis has been done. So number one, for the high-rise tower, the wind analysis are very important. Any high-rise tower which are probably more than 30 floors, 30 to any limits up to 100, 120 floors like that. So wind pressures calculation or maybe the following up the wind tunnel test reports are very important, because in a tower, one single tower or a multiple tower, I'll just put it on the screen over here. You can see some of the high-rise tower which we have been done in the past as a facade designer. So on the left-hand side, there's a 106 floor in Accents Tower in Kuala Lumpur. Then the Mahanakham Tower in Bangkok. These are certain high-rise towers where how do the facade design consideration can be done. The wind load calculation or follow the wind tunnel test reports. But when you have a wind tunnel test reports, there is certain pressure coefficients to be added up when it comes to the opening percentage onto the facade. The secondly most important are how the buildings can make it energy efficient. Which are the various factors or importance where the energy studies can be done. So first is the sun path. So of course the architect, they go run through the sun path analysis on the overall the layout. But when it comes to the facade, like mostly the sun path analysis helps a lot to decide the parameters of the glass, what kind of visual light transmission is coming. Mostly the office towers or hotel, what they need to have, that we allow nowadays the modern facade is that maximum daylight to come in and cut the glare, cut the heat control over there. So daylight analysis, the shadow analysis, the thermal analysis is very important, because sometimes we follow the lead value, like let's say U value of the glass is 1.6. So that is the U value of the surface of the glass. But what about the aluminum? So aluminum is a good conductor of heat. So who is going to analyze the combined analysis of the thermal UCW value or maybe total solar heat gain? These are all analyses are very important. Not only define the parameters of the designer. Like if you have a proper, which you call as, for example, in place in Delhi, where you have a maximum at the summer is 40, 42 or 43 or 40, 38, 39. So, and inside during the temperature control is 24, 23. In the winter season, it's opposite. So the adaptive design facade, how can we help to design the facade into adaptive, to control the heat gain from outside to inside. And it helps the whole, the air conditioning design can be controlled. It can be designed in a proper way, not over-designed, under-designed. Glass can be selected in such a way that, there's optimization, a lot of optimization can be done in terms of. So these are very important analysis which we need to factor during the for any high-end office or office complex where there is a centralized air conditioning, and also the residential project like some high-end service apartment where you have a centralized air conditioning, or maybe a floor air conditioning where you can have lot of optimization in terms of heat control. So being as a facade engineer, or I would say that only the facade consultant, but facade engineering need to be addressed at the beginning with the architect, and can work as a team to find out the right proportion on the of the material selections, the analytical part to have the proper calculation. And another thing is that, okay, there's sometimes many projects we have a platinum rating or rate of rating at a gold or platinum or silver. So how do we achieve that? When you call it a platinum, we always have an impression that, oh, we can go with a very high-end system, maybe thermal break system, or maybe a high-performance glass where we can lower the U value. To achieve those, we need to have a very smart analytical method, like how the system can be designed in such a way that it caters to that requirement. Not only just getting into a thermal break system, adding up the cost. So the smart analysis not only can give a sustainable design or the energy efficient design, but also it can optimize the overall cost of the facade. So that is the another factors which are important. So regarding today's topic is the high rise. So high rise, the wind is a very important factors where you have a surface condition, you have a corner conditions. So wind acting on the surface conditions are different, corner conditions are different. So maybe the corner conditions or some non-typical areas where, as per the architectural facade, the design intents are different. For example, this is a tower where the architectural intent are different. So it's breaking in between. Or maybe this tower you have at the top, they have the lintel double screen facade. So the wind consideration on the central on the surface condition and corner condition and the top conditions are different. So the corner conditions are always maybe 20-25% of the whole surface area of the facade. So we don't need to consider the highest wind load to design the overall surface of the facade. We can take the surface condition and design something smartly where the corner condition can have a composite way of aluminum and reinforcement inside to make it as per the design requirement. So these are certain very important factors like the facade designer or a facade consultant should address, so that it can give an overall benefit not only to the project owner but also the end user comfort. Because ultimately, when you have the building in operational conditions, so you need to have a very pleasant, the control of the comfort level inside, whether it is just sun protections or maybe the weather barrier protections or noise level protection. These are very important factors. Another I would like to highlight is that when we have a double glass, we all know that double glass, insulated glass, you have a first layer and the second layer with an intermediate of the airspace. So mostly the airspace are used as a 12 millimeter airspace between the two glass. But what benefit are you getting when you increase the airspace from 12 millimeter to 16 millimeter or 20 millimeter? So the benefit is that if we increase the air gap from 16 to 16 millimeter from 12 millimeter, there is a 4 to 5% of energy saving of the whole of the building. So 4 to 5% of the energy saving per year is also a substantial cost saving onto that. So these are certain important aspects of the design which need to be considered before we get into the designing of unitized system. Of course, the high-rise towers have always been unitized system. The benefit is that it's a prefabricated product. You can bring and install at the site. It's a complete one-stop solutions when you use, and then we have no other work to do. And for high-rise, the scaffoldings are not possible. Yes, we all know about it. But I would, as a facade consultant, and we are working with the many international projects has been shown in this one. So these are, I do feel that very important for all of us to understand that what are we going to design, what are we going to achieve it based on to the lead requirement, as per the architectural intent to fulfill the intent, how do we structurally can resolve all this detailing, and also the thermal performance, the performance of the building, so that overall we can have some benefit to the building owners to meet the architectural, the concept intent or architectural dream of any projects, because they work very hard to design something, and if it comes fulfill it as per the requirement, then it's very good way to handle it design. So I do feel that it's very important for us to give importance onto the design first, and design initially takes a lot of time if we do the right in coordination with as a team with the architect, with structural consultant, with MEP consultant, all these factors. So I just wanted to show you a few of the projects which has been over here. I'm really I'm sorry for the inconvenience to the mobile. This is another twisted building. How do we achieve the facade design? And this is in Bangkok, which have been done in the past. See the real images of how the facade has been twisted. And this is, again, a LEED certified projects. Then we go another one, which is one of the iconic structure, which is they claim to be in Southeast Asia. It is a 50-floor, like a diamond crown. Diamond crown. This is how this complexity of the design at the top. These are all structure, the concrete structures, and the unitized facade is connected. There are a lot of different types of the glass. There's a screen on the front, double screen on the roof. So the complexity of the design has to be resolved at the beginning to make it in a proper way as a form of the tender to the facade contractor to understand that what the client is looking for, what is the architectural intent requirement, how the facade can be treated. So it has to be in a proper way to design in the form of the tender to float it to the facade contractor to understand. Few different, these are the different breakouts on the facade where the wind applications are different, the energy studies are different because every the blocks acting in a different in different directions on this. So if you look at the other, like this is the Hyatt Regency, you have different the geometry of the facade to be addressed. So this is how the high-rise facade structures can be treated in terms of the design intent. So what the end of my discussions, like I just wanted to stress in one thing is that any facade which is to be designed, which is of a project to be treated properly at the initial stages along with the architectural team to find a way, to find a solution in the right way, optimize in terms of the performance, in terms of structural stability. Have to look on the architectural intent to follow as per the concept and so on. So this is all about from me, and of course I'll be very happy to present whenever in the next time in a proper way, but I'm really sorry for the inconvenience happened today. Thank you.